Welcome to Devotional Algebra 2. Today we're going to begin our first unit, which is on regression, and the first lesson of that unit, linear regression. Let's jump right in. All right, the first thing I want you to notice is the green points on the graph. What we have here is a scatter plot that shows you the number of Christians that there were in the world at different years in history. So, for example, if you look at this point right here, you see that there's an x value and a y value. The x value is the year, AD 67, and the y value is the number of Christians that were estimated to be in the world at that time. You may remember how scientific notation works. This is just telling you how many times to move the decimal point to the right. So if we move the decimal point 1, 2, 3, 4 times to the right, then that would mean that we have what? 95,710 Christians roughly in the world in AD 67. And then you can keep following these points all the way through, right? So here we have in AD 100, 861,000 roughly Christians in the world. In AD 150, we have just under 2 million Christians in the world, and so on. So that's what the scatter plot represents. The next thing I'd like to show you is a function that we have represented right here, n of x. Now you may or may not remember how functions work very well from Algebra 1. We're going to be talking about functions a ton in Algebra 2. In one sense, that's really what Algebra 2 is all about, is the study of functions. Now, this function looks kind of complicated, and please don't worry about the details of it right now, but let me just remind you what a function is. A function is simply a mathematical relationship between two sets of numbers, and it's based off of a rule. Think of a function like a machine. You have a machine. Imagine inputting numbers into the machine. The machine follows some kind of a rule and then spits out an output for each input. That's all a function is. So, for example, let's imagine that we plug the number 50 into this machine, okay, into this function. What's going to happen is every single time you see the x values that's the input that you're inputting into the machine. So let's say I input the number 50. Okay, I'm going to type the number 50 right here and input it into the machine. What's going to happen is every x value that you see is going to get replaced with the number 50. The machine's going to follow the rule, and it's going to spit out an output. So I type in the number 50. Notice, every x value got replaced by the number 50. So what did the machine do? It took the number 50, and it raised it to the power of 3, multiplied by this number, and then it took the number 50, raised it to the power of 2, multiplied by this number, and it multiplied this number times the 50, and then it added all these numbers up, and it gave us this value right here, 79,166. Notice that point, right, when x is 50, the y value is 79,166, right? That's showing up right here on my graph. Okay, let's try another value. I'll plug in 100 this time. When I do that, each of these x values will get replaced by 100. The machine follows the rule. It spits out the value. And this time the value that it spits out is 771,554, and you see where that's located right here on the graph. If you keep plugging in all these different x values, what you're going to get is this blue curve that's graphed right here. This is the graph of this function. Now here's the amazing thing. When you do that, notice how close this blue curve is to the green points for the number of Christians in the world at those different years in history. I mean, let's try plugging in 150 into this machine and see what we get. Plug in 150. That's scary how close that is to the green point. It's almost exactly the same. Let's try plugging in 300. Again, that's almost exactly the same value that actually happened in history. Most people know that God uses math in his governing of his physical universe in science, right? Biology, chemistry, physics, things like that. But many people don't stop and think about the fact that it's not just science that is based off of math, but even God's governing of history. I mean, think about this. In the early church, Christians were fulfilling the Great Commission, sharing the gospel with people. And ordinary human beings in history were responding by either believing in the gospel or rejecting it. And in all those human decisions that are being made, behind it all, you see this mathematical pattern emerging. God's perfect plan is emerging mathematically in his governing of actual history. The mathematical relationship that exists between two things, we call it a correlation. The prefix co, like coordinate, corporation, it has to do with more than one thing that are related to each other. And then, of course, the word relation means relationship. So correlation is when you have a relationship, a mathematical relationship between two things. Now, not every correlation is equally strong. We looked at an example in church history where there was a very strong correlation between the growth of the Christian church and this function that we were able to come up with. Like the graph of the function very closely modeled the actual events in history. But not every mathematical relationship in life is like that. Sometimes you have something of a mathematical pattern, but it's not nearly as clear or as accurate. So let's look at some examples and see if we can figure out which ones would be strong correlations, which ones would be weak correlations, and which ones would not really be a correlation at all. Let's look first at the graphs here. Of these three graphs, which one would you say has a strong correlation? Would it be this graph, or this graph? This is the graph that has the strong correlation. You can see that of the three, this one, the points really very closely line up on a line. There's a very strong correlation between the points of on this scatter plot and a line that we could draw through it. So this would have a strong correlation. This graph would have a weak correlation because the points are not totally random. They do basically follow an upward pattern, but they're way more scattered. They're not nearly as closely aligned or following as close of a mathematical pattern as the first graph that we looked at. So this would be the weak correlation, and this one would have no correlation. The points are, as far as we can tell, totally random. Let's do the same thing with our words that we have down here. The strong correlation would be between our grade point average, someone's grade point average, and their SAT scores. There is a strong correlation between those two things. Students that get really good grades typically also get very good SAT scores. It's not always the case. I've known exceptions to that rule, but there's a very strong relationship between those two things. So that would be a strong correlation. The weak correlation would be between the grade point average of a student and their siblings' grade point average. In my experience as a teacher, there have been times where I've taught students that got really good grades. They were excellent students. And then I taught their sibling, and their sibling was exactly the opposite. But more often than not, that's not the case. Usually when I teach students, if I end up teaching their sibling as well, they typically are similar in strength or weakness as a student to their siblings because they grow up in the same household and they have similar genes and so on. But it's not going to be nearly as strong of a correlation as one individual's grades and their SAT scores. So this would be, I'd say, a weak correlation. And then what about between a person's grades and their height? Do tall people get better grades than short people or vice versa? No, as far as I'm aware, there's no relationship whatsoever between someone's height and their grades. So this would be no correlation. We can also categorize correlations not just in terms of how strong they are, but in terms of whether they're positive or negative. So let's again look at the graphs first and see which of these two graphs, the blue one or the orange one, would you say has a positive correlation? Remember, when you read a graph, you always read it from left to right. So notice for this blue graph, as we go from left to right, the blue points seem to be dropping, going down. This would be a negative correlation because as we go from left to right, the points are going down, not up. On the other hand, with the orange graph, as we go from left to right, the points are basically moving up. So this would be a positive correlation. Let's do the same thing for these words, these relationships here. Would you say that there's a positive correlation or a negative correlation between the number of hours you study and your test scores? Some of my students would disagree. I've had a number of students argue I think not with total objectivity, that the more they study, the worse their test scores are. But this is not typically the case. Typically, the more you study, the higher your test scores are. So this would be a positive correlation. As the hours of studying goes up, so do the test scores. So this would be a positive correlation. But the mileage on a car and its value actually has a negative correlation. Why? Because the more miles you put on your car, the less the car is worth. Because don't keep their value, they're not worth as much when they have more miles on them. So this would be a negative correlation. As the mileage goes up, the value of the car goes down. We can actually measure how strong a correlation is with something called the coefficient of determination. It's symbolized by the symbol r squared, and it's going to give you a number, a rating, if you will, of how strong the correlation is. So right now you see I have these points, and they're sort of following a line, and it's saying that the r squared value, the coefficient of determination, is about 0.62. Now, you can think of this number sort of like a percentage of accuracy. So it's sort of like saying that this line is like 62% accurate as far as representing the points. That's not exactly what it's doing, but it's sort of like that. So notice, if I make these points super spread out, like they're not following any kind of pattern, there's no correlation. I'm going to make them as scattered as possible. You can see what's happening is the r squared value is getting very, very close to 0. Because what that's saying is that the line does not model the points well at all. There's basically no correlation between them, right? But if I get these points closer to being lined up, watch as the r squared value gets closer and closer to, well, what would it be? If it's perfectly accurate, that would be 100%. So you can see now we're about at 86%, and now we're up into 96%, right? The more these are lined up, the closer, the stronger the correlation, the closer the r squared value will be to 1. So 0.999 or 0.99 is really, really, really high.